Very, very important. Also supplying the largest work area possible. Again, that greatly benefits the contractor's operations. The more room he has to work, the more efficiently he can work, and the quicker he can work. And again, that's going to reduce your costs. And as we all know, in this day and age, we're looking at costs. That's the number one driver in almost everything we do, is the first cost. And increased safety. Again, with a larger work area, less exposure to traffic for the contractor, for your inspectors, and for the public as well. Also, when you're looking at staging, you need to consider performing as much of the work as possible prior to placement. And when we start talking about full depth repairs and partial depth repairs, you'll see one of the big issues, or one of the things that has to be done, of course, before you can repair, is removal of the material. And removal of the existing material is going to require saw cutting. So doing some of that saw cutting ahead of doing your saw cutting one day and coming back the next day and doing your repairs, that can save you a lot of work. Getting as much of that done in different stages ahead of time before you actually start pulling your material out and doing your repairs. And so if you do your staging properly, you're going to reduce your user impacts in the long run. And even though I said giving a longer window and supplying a large area, both of which would imply we're going to increase user impact. But in the long run, you are going to reduce the number of closers that are going to be needed. You're going to increase your production rate, and you're going to reduce your user impacts. A good example, I'll show you just a quick example here, and then a real-life example from a project in Tacoma. But another thing to consider in staging is increasing the length of your work zone to make sure, or to incorporate as many repairs as possible in a given area or in a given closure. If you've got some repairs to do in one location and then a half mile down the road some repairs to do in another location, don't do two separate closures. Don't do it over two separate nights. Consider combining those all into one closure. Get them done as quick as possible and get in, get out, and get it over with. And a slightly longer closure time can greatly increase your productivity. Just as a quick example, we're frequently faced with an 8-hour work window. Let's say 10 p.m. to 6 a.m. or 9 p.m. to 5 a.m. to get in, get it done. A very liberal assumption would be that it's going to take the contractor an hour to get traffic control set up, get equipment in place, and get started working. And then it's going to take him an hour on the other end to clean up. So if you've got an 8-hour closure, he's got 6 hours of working time. Now, if you increase that to a 10-hour work window, he gets 8 hours of production, assuming the same hour on each end. So a 25% increase in your closure time gives the contractor a 33% increase in production time, which is going to bring your unit costs down. And that's going to get your project done quicker. And a good example of how this can work, and those of you from Washington State will be very familiar with this. Jeff, I know, will be familiar with it. Dave Luer, probably very familiar with this project. Tim, I think I saw Tim Muma, you still here? So, Tacoma panel replacement. 40-year-old existing concrete pavement. It was exhibiting some random panel cracking. The length of the project was 2.5 miles. The design was to replace 29 panels. That doesn't sound like a lot over 2.5 miles, and that's not a huge amount. 29 panels, 580 square yards in 6 separate locations. The original plan, the original schedule for this project called for 12 working days, 4 3-day weekends with closures only at night, 11 p.m. to 5 a.m., 10 p.m. to 10 a.m., et cetera, with traffic restricted to 1 lane. 4 weekends, 12 working days. The contractor went to the DOT and said, look, if you'll give me all weekend, not just the nighttime, I can get all of this done in 1 weekend. And so the DOT looked at it and said, well, there's going to be huge traffic impacts if we do that. The contractor agreed to bring in extra traffic control signage. There was some more public information put out, public information campaign. So the contractor was given permission to do it in one weekend. Friday night they started saw cutting and drilling. Saturday 8 p.m. to noon they were placing concrete. They used the collector distributors for through traffic. They closed the main line. They kept one lane of traffic open. The DOT had been concerned that under their existing models, the queue lengths in that construction zone would get up to 6 miles. But with the additional traffic control the contractor brought in and the public information, I think the queue lengths never got over about a half a mile in length. And as a result of this, giving a longer work window and greater work area initially, the contractor was able to get all 29 of those panels replaced in one weekend. So ultimately, in the long run, we reduced the exposure of the contractor and the public and the DOT to safety issues. And it got it done much more efficiently, effectively. Everybody was a lot happier with it. Get in, get it done, get out. Stay away. So the benefits that you can get from taking a long, hard look at your staging. Safety, safety, safety. Number one priority. Less public exposure, less worker exposure. Another benefit to doing it like this on the Tacoma project was once you get your plant geared up, you get everything dialed in, you're making your production, you're not starting and stopping as much, so you're going to get more uniform mix. You're probably going to get better quality control. Giving the contractor a greater area to work and more time to get each one of those patches in place, he's going to do a little better quality work and you get better ride. Lower overall traffic impacts, and the number one thing is public perception. Now the public's happy because they saw, yeah, I was inconvenienced for one weekend, but you got in, you got it done. I'm not experiencing inconveniences for multiple weekends. And I think that's something we've seen not just with pavement repairs, but with construction in general. Getting it done, get in, get it done, inconvenienced me a little more at first, but get it done quicker. And the public is generally happier. So again, the construction schedule on that Tacoma project Friday night, saw cut panels, drill lift points, set traffic control, begin removing panels. The final concrete pour was at 4 a.m. on Saturday night, and on Sunday at noon they were ready to open it to traffic. They didn't even need all the way through Monday morning. 29 panels done in that shorter weekend closure, or that longer weekend closure, but they got 29 panels done and actually a little bit ahead of schedule. So staging is one of the biggest issues for getting rapid repairs done. Now, let's assume you've got the project staged properly. If you want rapid repairs, you need something that's going to be able to gain strength rapidly when you're putting concrete in place. So you have some options. For full depth repairs, typically you're looking at a high early strength Portland cement mix if you're going to be casting in place, or a high early strength non-Portland hydraulic cement mix. And they both have pluses and minuses. And there's another option you have. We haven't used it yet here in the Northwest, but I know it's been used in other parts of the country. I can't speak to it a great deal, but I'm sure there are other people who can if you have questions later, which is precast concrete panels as well. That's another option that you have. But for your full depth repairs, the pluses and minuses, one would be a standard high early standard Portland cement or ordinary Portland cement mix. Probably a lower material cost, at least somewhat, maybe not always, but probably a slightly lower material cost than some of your other non-Portland hydraulic cements, but as sacrifice a slightly lower rate of strength gain. Some of the best mixes I've seen, we can get opening strength in 4 hours or so. When I was in graduate school, I worked on the Sharp High Performance Concrete project, and we developed mixes there that were pretty exotic, pretty tough to work with, and even with those, we were looking at a 3-hour opening time. So you're looking at 3 to 4 hours, best case, for an ordinary Portland cement mix. If you can stage, that's great, if you've got the time to do that. If you don't, you're looking at a high early strength non-Portland hydraulic cement, calcium sulfoaluminate cement, something to that effect. Typically a higher material cost, but a much more rapid rate of strength gain and an earlier opening time. With these mixes, you can get 3,000 psi in an hour or less, so that you can get traffic on that very quickly. You can get that placed and open it up to traffic. So those are your materials options really for full depth repairs. I suppose you could consider for full depth repairs some of the polymers, but I think that would just be prohibitively expensive to use polymer cements in a 9-inch, 10-inch, 12-inch pavement. I just don't think that would be possible. For partial depth repairs, however, you have the same two options as you had originally. You have your high early strength cements, whether it's a high early strength Portland cement like a type 3 mix, or your high early strength non-Portland hydraulic cements. And I think for these types of partial depth repairs, you'll see either the high early strength non-Portland cements used much more commonly than standard OPCs, or polymers. And when I say polymers, I'm talking about urethanes. There are urethanes available, epoxies available, polyester concrete. There's a variety of materials that can and do work. The benefits to them are that they gain strength very rapidly. With some of these, again, you can put traffic on them within an hour. They're very easy to mix in small quantities, which is frequently what you're dealing with these partial depth repairs. When you're looking at a hydraulic cement mix, you can mix those in smaller quantities. Generally, you're looking at using a mobile mixer, a volumetric mixer, something of that sort for doing those. There's nothing wrong with those. They work very well, and if you can accommodate that in your schedule, that works great. But if you need something or you choose to use the polymers, those are out there, and just be aware of those. Some things to consider, though, with the pluses and minuses of the polymers versus the hydraulic cements. Again, polymers, very rapid strength gain, 1 to 2 hour opening time at moderate temperatures, depending on the material you're using. One of the benefits is they are relatively flexible and durable. They're very durable. What we've seen, certainly with some of them, can stand up, even with the polyester concretes, I know are standing up well to studded tire wear for us up here in the Northwest. However, not all of them are suitable for application in damp conditions. I know some of the epoxies can be used in damp conditions. I know polyesters some of those can be used in damp conditions, but the urethanes, some of them can be difficult to use in damp conditions. So you need to consider that when you're scheduling your project, what season it's going to be, what the weather might be. So not all of them are suitable for those conditions. And again, they're typically mixed in small quantities, which can make them very easy for smaller projects, make them very cost effective. Even though they are relatively expensive, if you're just doing a few small repairs, it's probably pretty cheap to do that as opposed to bringing in a mobile mixer or something of that effect. Of course, with the cements, you can also use prepackaged and mix them in smaller quantities as well. And just to show you what some of the polymer repair materials look like, they're going to look with the cement-based materials. Once you put them in place and they've had a little time to age, you're probably not even going to be able to tell there's a repair there, particularly at highway speed or if you diamond grind after you do your repairs. With the polymer materials, they may be a little more noticeable if that's an issue for you. I know some of them can be colored, but they're going to show up a little bit more. However, they are very durable. That's just one of them. I believe that's a urethane patch, and those are working quite well. And then another one of the polymer patches with the aggregates in it, the extender aggregates in it, and those are very durable and can work very well. Again, they're a little more difficult to work with, but they do set very rapidly. So those are your choices on the materials. Now, let's say you've selected your material. How are you going to do this repair? And this is the #1 problem that we see in the field, is improper construction practices leading to failures and then leading to the blame of, typically it's the material. The contractor will say, oh, it's the material. Well, I've seen the same material go down with an experienced contractor and last quite well and perform quite well, and go down with an inexperienced contractor and come out within even a few days or a week or a few weeks. So procedures are critical. All of the materials can and will work well when installed properly. So basically 3 steps in doing any one of these, whether it is a full depth or a partial depth repair. Removal of the existing and or adjacent material if necessary, preparation of the patch area, placement of the material. So let's talk just about some of the key issues with those. For partial depth repairs, typically they're going to be used to address deterioration at the top of the slab along joints, joint spalls, spall repairs like that. As a general rule of thumb, we don't want to go with a partial depth repair below about 1/3 of the depth of the slab. If you've got to go deeper than that, go ahead and do a full depth repair. If you go half depth, you're going to leave something that's likely to fail, likely to crack at that interface. Frequently or generally they're located at joints. However, we do see some of them mid-panel, but most of the time these partial depth repairs are performed to address joint spalls. Joint spalls that have happened because joint sealants or fillers haven't been maintained, or you've gotten incompressible materials in the joints and caused some sort of a joint spall. When laying out your partial depth patches, as a general rule, we like to see go a couple inches beyond the edge of the distressed material. Again, a couple inches, 6 inches max typically, and you want to go all the way down to the bottom of the spall with your saw cut, or close to the bottom of the spall. Now I show here a square patch and being done with a saw cut, and one of the issues with the saw that you have to deal with is that you're going to have run out on either end of that saw. I've got a contractor, and I'm sure there are others that have done it as well. I think it's a pretty neat and innovative process, using cores rather than saw cuts to do these partial depth spall repairs. So that's another option that you can do. They just take a core drill and core adjacent to each other, and then come in with a saw and just saw off that little point that sticks out in between. Great procedure, easy to clean out, leaves a curved edge instead of a sharp corner. They seem to be very, very durable. They seem to hold up very well. I can't say for sure, I haven't done research to state unequivocally that they hold up better than the square saw cuts or squared corners, but just anecdotally I've seen them holding up very well. So that's another option for removing these. So you're going to do your saw cuts or your cores, chip out the loose material, or chip out your repair area, and it's very, very important to make sure you get down to sound concrete all the way across the bottom. If you don't get that very clean, get all the deteriorated concrete out of there, your repair is not going to last. It won't bond, it won't stay in there. So you've got to get all the way down to sound concrete, and you've got to get that area very, very clean for these repair materials to bond and to stick. Another option, if you have a great deal of repairs to do, let's say you have a great deal of spalling on a longitudinal joint, is you can use a mill and mill directly adjacent to that longitudinal joint for a great length. Things to be aware of with that is, if you're using a standard mill head with the standard tooth spacing, you need to be careful with those. Make sure that the contractor increases the head speed, reduces the downcut pressure a little bit so that they're not leaving micro fractures in the remaining material, and that they make sure they get all loose material cleaned out of there. There are also micro mill heads that have more finely spaced or closer spaced teeth, and those don't provide quite as much impact force to the concrete, and they leave a better surface finish, something easier to work with when you're doing your patching. So that can be done for large projects. As far as the details in placing the material, one of the very, very important things is to remember that when you're doing a spall repair at a joint, that joint is probably open somewhat, unless you're doing it, I guess, on the hottest day that it's ever been, and it's only going to open from there. That's probably not the case. That joint is going to be open somewhat. So if you place that repair material and you place it all the way up against the adjacent concrete, whether it is at a transverse joint or a longitudinal joint, when that concrete starts to expand or move, you're going to get point bearing, and you're going to pop that right out of there. Now, you may think that's not an issue on a longitudinal joint. Let's say we've got a joint tied. That joint's not going to open and close a lot. But remember that on that longitudinal joint, if you get a truck tire right on that joint, you're going to get some deflection. And if you've poured that patch right up against the adjacent slab, even on a longitudinal joint, you're going to get deflection, you're going to get point bearing, and you're going to pop that patch out of there. So it's very important to make sure that the contractor installs some sort of joint reforming material to make sure that that joint is put back in there. It can be saw cut back in after the fact as well, but it needs to be done very quickly before you get traffic back on that to make sure that you're not going to pop that joint or that spall repair material out of there. And here you can just see one where all four corners have been done and they've put the joint reformer in there. It's also important to make sure that that joint reformer extends beyond the edge of the patch and also below the patch. If it doesn't, then you will get mortar flowing out of that repair material out into the sides of the crack or down below the spall repair and the crack, and it's going to fill that joint up. It's not going to be able to close, and again, you're going to get a joint failure. For some joints, it may be tough to get that joint reformer material down into that crack and get a good seal. One option that I have seen used, and it works very, very well, I've seen contractors come in before they put the reform material in there and just run a quick bead of silicone caulk around that crack, then set the joint reformer in place. And that's just to make sure that you don't get any of that grout material down in there. And that works quite well. So here we just have then a finished patch, and you can see it blends in very well, and if it's ground, you'll never even notice it. And they can last for a very, very long time if they're done properly. Full depth repair, pretty much the same as placing full depth concrete pavement, generally used for utility cuts, corner breaks, broken slabs, joint deterioration, things like that where we want to cut out the whole joint. The key issues to be aware of there is isolating the longitudinal repair boundaries when we're doing shorter repairs. We have found that if we don't put an isolation material and we put tie bars in there and it's just a single panel or two panels, that we can get enough shrinkage to cause and enough stress to cause some random transverse cracking in those areas. So it's a good idea to isolate those longitudinal joints rather than tying them. If you've got a lot of joints close together, try to combine them into one larger patch. So with these, you're typically going to saw cut full depth. Remember to make sure that you do 2 full depth cuts around the perimeter of the patch. One around the perimeter, one slightly inside that, 4 inches to 6 inches, a relief cut, to make sure that when you're removing that material, you're not going to damage the edge of the material that's to remain in place. They can be lifted out like this, drilled and pinned. I also know there's a new suction device. I didn't get that photo in here, but that patch can be cut up into smaller sections. There's a suction device that can be attached to a skid steer, and just grab a hold of that and lift that piece of concrete right out. And then when you're doing jointed pavements that are doweled, you're going to definitely want to reinstall or restore your load transfer. You can put 12 all the way across the joint, or 12 inches all the way across the joint, but I don't think that's necessary. We've seen the finite element analysis that shows typically 3 bars or 4 bars in a wheel path work quite well, and we've got a great deal of experience. And you can ask Dave, you can ask Jeff Ohlmeyer, anybody here with the dowel bar retrofits in Washington State, and we know that the 3 bars per wheel path work quite well. They last for a long time. So when you're drilling in your dowel bars, you can save a little bit of money on steel cost and labor cost by not putting 12 bars across there, but cutting it to 8 or even 6. Compact the base, do any prep that you have to do, and then isolate the side, place your material and finish it, just like placing any regular concrete pavement. And these can be done again with the rapid setting type cements, the high early strength, quick setting, non-ordinary Portland cement set. If you do intend to do a diamond grind after you do all these, you can allow them to be finished slightly high, about 1/8 of an inch or so is a good idea, and then you can come in and grind it smooth and make sure you get a good smooth riding surface out of your finished product. To sum it up, I'll say that concrete pavement repair is not that hard to do. It's nothing to be afraid of. I know maintenance crews get afraid of it. We can't do that. We've never done it. I know one state DOT that I was dealing with was advising a local agency to do concrete in a downtown area because by their calculations it was even going to be cheaper first cost, and the local agency refused because they were afraid of doing maintenance. They'd never done maintenance on concrete pavement. It's not hard to do. There's a lot of good contractors out there, and there's a lot of expertise in the industry to help you if you choose to do, and if you need to do, some of these rapid repairs for your concrete pavements. So with that, I'll take any questions. I know that was a very quick run through on it, but I'll take any questions anybody might have. The question was, if you're doing slab repair, is it good to replace the gravel underneath? It's good to compact it. If you find it soft underneath, then yes, you're going to need to dig out and replace some of it. Typical, you'll dig down about 2 feet or dig down to solid material, replace it with good material and recompact it. If it is in good shape, you don't have any soft spots, there's really no need to replace it. Just run a plate compactor over it, make sure it's good and solid, and place your new concrete pavement on it. Also, if you do find that the base is contaminated, or I know in some areas you may have asphalt base under it or something, if that gets ripped up with your patch and you don't want to take the time to put that back down, you may find it actually cheaper, rather than trying to bring in another contractor to do that and put in 2 or 3 inches of asphalt underneath, to just make your concrete slab thicker to accommodate that. So look at those factors when you're planning your projects out. The question was, is there any kind of adverse reaction between the rapid set cements and the castings? Not that I'm aware of. They're just mostly calcium sulfo aluminate type cements. Yes, they are somewhat basic, just like a standard ordinary Portland cement, but they're not going to have any major reactions with your iron castings. And now that said, I think it's always a good idea to isolate your castings, just to make sure that you don't end up with a slab suspended in midair or ripping a casting off the top. But that's another design issue as far as isolation joints and things like that. The question was why the maximum cut depth for a partial depth spall repair of 1/3 of the depth. There has been experience that if you go down half the depth, well, if you've got steel, number one, you're going to get into your steel, your dowel bars, tie bars. Number two, that you may weaken that enough that you get a crack at that interface down below. Even though you've got that repair material bonded in there, there may still be a weak plane and it cracks below. So the experience has been, and it's purely empirical, that limiting it to 1/3 of the depth of the slab is the best practice to make sure, or to minimize the risk of a crack at that cut corner, that inner. All right, thank you very much.
Additional support provided by Michigan State University.